Hi, I'm Tristan and I'll be presenting my project titled Electrolysis Efficiency today. I was inspired to investigate electrolysis because I believe that the process of bringing hydrogen out of water will be crucial to renewable energy resources in the coming years, and I wanted to find out the most efficient ways in which hydrogen could be split from water during electrolysis. Also, my mother has had a background in environmental engineering, so I kind of had a base to start off there with, and I was very interested in that sort of thing. Firstly, I researched some of the main variables and components of electrolysis. Now, electrolysis is a process in which an electric current runs through a solution which has an electrolyte in it. This electric current is then able to split the solution down into its base elements. In the case of water, this is hydrogen and oxygen. The electric current will run between two electrodes, an anode and a cathode. So in water, the hydrogen ions are positive, and they will be attracted to the negatively charged anode. And the oxygen ions are negative, and they will be attracted to the positively charged cathode. So in this experiment, I used a 500 milliliter beaker, which was filled, this is a 1,000 milliliter beaker, but it was filled with 500 milliliters of distilled water in each trial. And then I would use these graduated cylinders to place over top of the electrodes so that the gas that would collect at them could then be measured as it would bubble up into the tube. Now, I ran 12 trials over the course of 5 minutes, or each trial lasted 5 minutes, and I tested 3 different variables in those trials: the concentration of the electrolyte solution, the temperature of the water, and the strength of the electric current. The electric current was varied into 2 different sets, a 9-volt and 12-volt set. The electrolyte concentration was on 3 different levels: 1 teaspoon, 2 teaspoons, and 3 teaspoons. And the temperature of the water was also on 3 different levels at 30, 35, and 40 degrees Celsius. I found, after running my test, that the most significant factor in producing hydrogen, the factor that produces the most, what I found, was at 3 teaspoons of baking soda in your 500 milliliters of water, the 12-volt battery, and at room temperature. That was what I found had produced the most, and from the base control test, I had seen a 275% increase in the production of hydrogen in just the span of 5 minutes. Now, I also noticed that the graphs, you'll see that the hydrogen outpaces the oxygen almost double. And this is to be expected, as, of course, in water, there's 2 parts hydrogen to 1 part oxygen. I also found that the temperature of the water had a significant impact on the effect of the amount of hydrogen and oxygen produced during the 5 minutes. I believe that the water temperature was impactful on this because the higher the ambient temperature of the water is, the easier it is for that electric current to break those covalent bonds between the hydrogen and the oxygen. This project, I think I would like to continue it in the future and test a variety of different variables. I'm interested to see how potentially water contaminants could affect how much hydrogen and oxygen is produced, and I would like to investigate the electrolyte concentration and see if perhaps there's a plateau or a peak where the amount of gas produced does not increase any further. But more importantly, above all, I think I would like to get better equipment. It worked, the project worked, but I think that with more advanced equipment and better measuring tools, I would be able to eliminate any human error and get more accurate readings and measurements on what I'm trying to accomplish. This research, I think, is going to be critical in the coming years. I believe that hydrogen technologies are going to rise to the forefront of renewable energy efforts. There's been much talk and development and projects into the field of hydrogen. There's been investigations into how regular natural gas and propane stoves can be converted into hydrogen stoves. Hydrogen fuel cells have been developed that can power cars, and there are even hydrogen fuel technologies on the ISS right now. A fascinating one of these is houses that are fitted with solar panels can use the energy from the solar panels during the day to run through a water tank, and the water tank can then, or a separate tank can then collect the hydrogen from that tank, and the hydrogen is burnt through the night to provide the house with power and heat. This means that the house is 100% eco-friendly and no fossil fuels are used to power it. This could be impactful, very impactful in the future, especially as the world attempts to fight climate change and other renewable or other environmental factors. Thank you for your time.